Hey y'all, this is the progress check part A from the College Board assignment. So on this first one we have parametric functions, and we want to know the second derivative and when is the second derivative equal to 1. So the first thing we need to do is find the second derivative. So dy dx with parametric, you're really just taking the two individual derivatives and then writing them as a ratio. So we've got t to the 7th minus 2t to the 4th, and dx is 3t squared. So I'm going to do the derivative of this again to get the second derivative, but if I leave it like it is right now, I'm going to have to do the quotient rule, which isn't like the worst thing in the world, but it's also maybe not a bad idea to rewrite this as individual terms instead of a quotient. So now when I do the second derivative, I'm going to have the derivative of the top over the original dx. So that's the part that you have to remember with parametric that's a little bit different. You can simplify that if you want. If you do simplify that, that's going to be, it's going to simplify to 5/9 t squared minus 4/9, 4/9t. And I want to know where that is equal to 1. So if this were no calculator problem, well, I mean, I could probably solve it, but it would be kind of hard because, you know, fractions and factoring because it has a t squared and a t and all that. But it's not a no calculator problem. So I can go to the calculator, and I typed this in wrong a second ago. I'm going to graph the derivative in y1, and I'm going to graph the line y equals 1 and y2, and I want to know where they intersect. So all of my answer choices are positive, so I'm looking for a positive number, and when I look at those and compare my answer choices, I can tell that the only reasonable answer is 1.525. So I could do calc, second trace, intersect if I wanted to, but I got the answer I was looking for, so I'm going to move on to the next question. This second problem is saying what is the instantaneous, or it's giving me the instantaneous rate of change. Okay, rate of change is derivative. So this is giving me the derivative here. And it's also giving me a starting point. It's telling me that f of 2 at time t equals 2, the x coordinate for this point is 2e and the y coordinate is pi minus 7. I want to know where it is at 6 seconds. So I know where it is at 2. I want to know where it ends up at 6. So what I really want to know is where does it start plus how much does it change to get where it ends up. That's kind of how these are set up. So I know where the x starts. I know that it starts at 2e. And I know the rate at which it's changing. So I need to know the total. Oh, I know a calculus thing for that. I need to know the total amount of change between when it started and when it stopped. So I know where it started. I'm finding the amount of change, the total amount of change, and I'm going to figure out where it ends up. This one is another calculator question. So you can type that into the calculator. Not here. 2e plus math integral 2 to 6 of e to the square root of x. Oh no. So There's your x coordinate. So, I mean, I could find the y coordinate, but I already know what the answer is. To find the y coordinate, you would have had your initial y value plus what is the amount of change of the y over that interval. And that's another one you could type in the calculator, but just knowing the x value told me what my answer was. So that one was about vectors. And we haven't talked a lot about vectors, and the reason that I haven't is because we've got some other things that are more important. Some of these vector questions, I feel like you guys could treat them the same way you've treated other things that we've done, and you would be able to figure out what you were supposed to do. Kind of like this one. I've got an initial value. I need to know the amount of change. So this really didn't even matter that it was vectors. On this third one, I want to know the derivative of the x. So the derivative of x is going to be derivative of the outside, leave the inside alone, times the derivative of the inside. So 2 cosine 2t. So not that one and not that one. And then the derivative of y. Derivative of cosine is negative sine, leave the inside alone, times the derivative of the inside, so B is the correct answer. On number 4, so we've got parametric functions. We want to know the slope of the tangent line at t equals 2. So slope of the tangent line is derivative, so I need to do the derivative of y, dy dt. So chain rule again, derivative of the outside, leave the inside alone, times the derivative of the inside, and then derivative of x is going to be 12t squared. So I can reduce 6 and 12. I can cancel out a t, so I've got 2t on bottom. So 3/2, I don't know the best way to write this, probably 3 times 3t squared minus 4 squared over 2t if you simplify it a little bit. And I want to know this one, t equals 2. So if you plug in 2, 2 squared, y'all would type this in the calculator, and that's probably the smarter thing to do. 2 squared is 4 times 3 is 12, minus 4 is 8, squared is 64 times 3. When you work all that out, it should work out to 48. So I need to double check my math on that, but that's how this one works. Do dy, do dx, plug in 2, and then simplify it. Problem number 5, which of the following is the expression for dy dx? So dy, derivative of e to the u is itself times the derivative of the exponent. So even though this is parametric, I mean it is technically, but also it's really just knowing your derivative rules. So I get negative 2e to the negative 2t over 2e to the 2t, so the 2's can cancel out. So when I have something that has a negative exponent, then I know I can flip that and put it on bottom, so that e to the negative 2t can go to the bottom. And then sometimes I forget my exponent rules. So like if I had e squared times e cubed, what would I do with the exponents? Well, I would add them and make that e to the 5th. Okay, so if I would add them, well, I guess that's what I need to do here. 2t plus 2t is 4t. And which one is that equivalent to? So we've got a negative. None of those are fractions, but if I flipped it to the top, then the exponent would be negative. So that's the correct answer. Second derivative. They ask second derivative because people forget what they're supposed to do on these. So Second derivative, well, obviously you need the first derivative. So the derivative of e to the 4t is itself times the derivative of the 4t. And then derivative of e to the t is itself. Dx is itself times derivative of 2t. And then derivative of 3 is just a constant. So that's the first derivative. The second derivative is going to be the derivative of the first one over dx. So if I want to work this one the way it is right now, that's okay. I'll have to do a quotient rule. But I also could maybe like rewrite this. That's 4e to the 2t, sorry, 4e to the 4t over 2e to the 2t plus e to the t over 2e to the 2t. So I can simplify and get 2. Subtract the exponents. 4t minus 2t is 2t. And then that would be 1/2. E to the 1t minus 2t would be negative t. So my second derivative is the derivative of the first. So itself times the derivative of the exponent. And then itself times the derivative of the exponent over the original dx squared. So there's some algebra that happens here. You can pause this and look over it if you need to, but that simplifies to a after you do some canceling and reducing stuff. So another second derivative, derivative of sine is cosine. Derivative of cosine is negative sine. So there's your first derivative. And if you wanted to rewrite that as negative cotangent, that would be okay too. So then your second derivative is going to be the derivative of the first. So derivative of tangent is secant squared. So derivative of cotangent would be negative cosecant squared. But this is negative, so that's going to make it positive cosecant squared over the original dx. So none of those answer choices look like that. I know I have a positive over a negative, so it's got to be negative. Cosecant is the reciprocal of sine, so that I could rewrite that as sine squared on bottom, and so that is negative 1 over sine cubed. So we're up to, let's see, number 8. So arc length, the length of the curve is really just arc length. So arc length is the integral of the square root of the derivative of x squared plus the derivative of y squared. So when you look at this one, I need the integral from -1 to 8, but the answer choices all have that. The part that I just wrote, that's just a memorization thing. You have to know the formula for arc length. So I know x of t is f of t, and I need its derivative, and I need it squared. And then y of t is equal to t. Well, what's the derivative of t? Just 1. So that would be 1 squared, which is really just 1 dt at the end. So that matches answer choice D. This one I thought was one of the trickiest of the problems that we've got. They like to do problems like this where they mix things together. So we're mixing together a graph that gives you a function value and a graph that gives you derivatives at different function values. So this function, when t is equal to 2, this function has a y coordinate of 2, and the y value is changing at a rate of 3 units. So this is telling me the function value for the x and the slope for the y. So they're parametric, so how do I get the arc length, the length of the portion of the curve? So this is an arc length question. So I know that I need to do the integral from 1 to 3, square root of the derivative of the derivative of x squared plus the derivative of y squared. Okay, so when I look at this section of the graph between 1 and 3, derivative is slope of the tangent line. So that function is linear. So what is this slope for that section of the graph? Well, slope, I can just look at this and tell that it's rise over run, so it's -2 over 1. So the derivative in that section is -2. So x prime is -2, and then I'm going to need to square it. They gave me the graph. They asked me the derivative. Derivative is slope. I can look at it and calculate the slope. This one is a little bit, I don't know. For me, it was a little bit trickier. Maybe not for you guys. I need to know the slope. If I needed to know the slope at 1, it's 2. You want me to know the slope at 2? I can tell you the slope at 3. Well, there's a corner there, so that might have some weird stuff happening. But you ask me the slope at those individual points, and I can tell you, but I need the slope between those points. So how am I going to get the slope for that whole section? Well, that section of the graph is linear, and I can write its equation. So the derivative in that section of the graph is the function. Let's see, the slope here is 1, so that would be 1x, and the y-intercept is 1. So the derivative for that is the function itself, which is a linear equation. And so there's the derivative squared. So when you start doing the math on this, you're going to have -2 squared, which is 4. If you distribute out the x plus 1 squared and then combine like terms, you end up with B as the correct answer. Don't be surprised when you see questions like this on the exam. They're going to give you things that are mixed together because really they're testing 2 different things here with one question. So, I mean, that's not great for me because if I know one thing but not the other, well then that might be a problem. But they're able to cover more material with fewer questions. So another length of the curve, another arc length question. I need to know the arc length between 0 and 3, so that's the integral. These are parametric, so I need to know x prime, the derivative of x, and I need to know derivative of y. So this is a product. X prime is going to be the first times the derivative of the second plus the second times the derivative of the first. Oops. There's x prime plus, now I need the derivative of y. First times the derivative of the second plus the second times derivative of the first squared. So which of these is equivalent to that? I mean, you can look through these and you can pause this and look through them if you need to, but it's this one. So again, this one was a little bit about parametric because you had to know the formula for arc length. But I feel like this one was also a lot about knowing your derivative rules. Do you remember how to do the product rule? Do you remember that you have to do the product rule? Because I feel like that's something a lot of people would forget. Okay, this is another one. Vector valued function. What even is that? Well, y'all have had physics, so you probably know. But even if you don't, this is giving me a function for x, and it's giving me a function for y. And it's asking me to find the derivative. So even if you just had to like take a wild guess about what to do here, you would probably be right. You take the derivative of the first one, derivative of the outside, leave the inside alone, times the derivative of the inside, and the derivative of y, derivative of the outside, leave the inside alone, times the derivative of the inside. And if you look through your answer choices, that's what D says. So even though this was about vectors and we maybe haven't covered that yet, this was really not so much about vectors. It was really about doing derivatives. So do the derivative of each one, and there you go. Oh goodness. On this one, I want the derivative and I want it evaluated at a certain point. This is vectors again, but it's really vectors and parametric, you treat them kind of the same, sort of the same way. So the derivative of this is going to be, the derivative of 2 cosine is negative 2 sine. And the derivative of 4 sine is 4 cosine. And then when you plug in pi over 3, negative 2 times, let's see, y coordinate for pi over 3 is square root of 3 over 2. And 4 times the x coordinate for square root of 3 is 1/2. So that simplifies to negative square root of 3 for the x and 2 for the y. And C is the correct answer. Okay, we're getting close to finished. So another one where I'm asking a derivative of something that has an x and a y. So I'm going to do the derivative of the x part. This is going to be messy. Derivative of e to the t is itself. Derivative of e to the negative t is itself times the derivative of the exponent. So you end up with plus e to the negative t times negative 1, so there's that. Second derivative of, second part, derivative of e to the t, and then the second one is itself times the derivative of negative t. And you want to evaluate this at natural log of 3. So that's e to the natural log of 3 minus e to the negative natural log 3. So that's 3 minus, I can rewrite this one as 1 over e to the natural log 3. And then e and natural log are inverses, so 3 minus 1/3. So that's 8/3. And the only one that has 8/3 for the x is C, which happens to be the correct answer. So which of the following is an expression for f of t? On this one, this is, again, they're using vector, things written in vector form, but it's not really about that. They want to know, so the position is the function f, and they're giving me velocity. So if I know velocity, how do I get position? Well, that's the antiderivative. So this is really an integral problem. So I need to do the antiderivative, the integral of each of those, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent, So that simplifies to 2t cubed minus t to the 5th, and then there would be a plus c out there. And so, let's see, not that one, not that one. Got to think about those. And for the y's, add 1 to the exponent, divide by the new exponent, add 1 to the exponent, and divide by the new exponent. So that was 6t to the 0 power, so that became 6t to the 1. So that is 3t to the 4th plus 6t plus some constant. That doesn't have the right y, so we narrowed it down. It has to be choice D. Okay, last one for this section. This one, you don't have to do any math. If you can, this is really how do you set up this problem. You don't have to work out this problem. So I want to know the position of a particle at a certain point of time, and I know where it started. So I know that this is starting at an x-coordinate of 3. I don't know what its y, well, I do know what its y is. It's -5. It's starting at 3, -5, and I have no idea what it's doing, but I want to know where it ends up. So what I really need to know is how much did it move left or right? I need to know to the total that it changed in the x direction, and how far did it move up or down? What is the total amount of change in the y direction? And if I know where it started and how much it changed, then I can figure out where it ended up. So which of these is going to tell me that? Well, this doesn't tell me, this doesn't have the starting points. So this one is out. If they ask me how far did it move, those would be fine because I don't care where it started, but they didn't. They asked where does it end up? Well, I need to know where it started first. So those two are out. The rest of this is details. When you look at this, those are different. So one of them's right and one of them's wrong. And if I know which one's wrong, then I know which one is the right answer. So when we're doing the integral here, we're doing the integral in terms of t. So which of those includes t values? Well, 3 was the x-coordinate. That was the position, but that wasn't the time. The time was 0. So it started at 3, and between the initial start, the starting point, and whenever it stopped, how much did it move? So C is the correct answer. And you could narrow that down just based on which one had the right numbers in the right place. So I know these problems, like some of them are tough, but they don't get easier unless you just do more of them. So I hope that this helped, and I hope that going through this helped you guys see a little bit about how they're going to ask the questions and how you should use strategies to kind of figure out the questions. And also maybe kind of reminded you of some things that you already knew, or reminded you how to apply some things that you already knew. So hope this went okay for you guys. Let me know if you need help with anything.